Brought to you by My Green Egypt, green resources for efficient energy.
Hello, my Green Egypt folks, and welcome to this second episode of this series of designing UPS systems. I've got some more of this cool UPS unit here, which is a Yamatsu Y2000 pure sine wave UPS. In this episode, we'll try to tear it down to have a look on what is inside. Maybe we can get some pointers that will help us in our attempt to design a similar UPS unit. So in a minute, we'll be testing it and then we'll have a look on what is inside. So stay tuned.
Hello again. I have this device set up and ready for connection. The connections are on the back of the device. We have here at this terminal block those two inputs are connected to the main supply, and in the middle you'll see the grounding terminal, and at these two terminals you will get the output supply, whether from the mains or being relied on the internal inverter of the UPS. Also, the device comes with two power cords. If you want to connect any of your devices which features a power plug, you can connect it here. Uh, the device gets its DC power from the batteries using those two cables. Those cables are connected to a battery bank, which comprises of two batteries connected in series. Each one of them is a 12-volt battery. Together, they will form a 24 volts output battery at a capacity of 7 amp hour. So let's now test the device. We will connect it to this extension cord here. You see, you heard that voice of the internal relay, and the LCD screen is operating now. You can see on the screen the device is charging the batteries. If we are going to connect one load on the device, it's a small fluorescent light bulb. You see, the fluorescent light bulb is operating now. It emits lights, and the load is connected to the batteries. No, now it is connected to the electricity main supply, not the batteries. When we disconnect this from the electricity's main supplies, you wouldn't even notice that the load has switched off. So the load continues driving its power from those two batteries. And now at the screen, you see the device stop charging the batteries, and it drives its power from the batteries instead. When we connect it back to the main supply, the device will wait for a second, and then it will switch it back to the main supply, and it will continue, or it will retain its charging status. Hello again. I've opened the device. I gotta be honest with you, I've investigated it a little bit, and it turns out to have few circuit boards here, few power transformers and coils, and from what I see, it has this first circuit board, which in my analysis, that circuit board cuts the way of the current passing through the batteries to the capacitor bank here on the second circuit board, and my judgment tells me that this circuit board is only used for self-charging the batteries.
If you have a capacitor bank and this capacitor bank is empty of charge and you have on the other side a battery bank, when you hook both of these sets together, then you will have a huge amount of current flowing from the battery bank to your capacitor bank. And that high amount of current at a time, after repeating this process many more times, it will damage your capacitor tanks. It will make uh, the liquid inside your capacitor, electrolytic capacitor, to dry out, and that will mean a degradation in the performance of the capacitors, and that will lower the performance of your device overall after many years. And of course, we don't want that in our devices to happen. And because they have put this port inside the device, that tells me that this device is well designed and well maintained. So they have done a pretty good job. And as we see here on the second circuit board, it has uh, four sets of transistors, most transistors, connected in a configuration of an H bridge. These transistors are used to generate the sinusoidal PWM outputs to be applied on the step-up toroidal transformer. This transformer will step up the sinusoidal PWM output from 24 volts AC maximum to 220 volts AC sinusoidally modulated PWM signal, and this PWM signal will be applied to a filter. I guess it is here, this filter here, and then it will be filtered out to form a pure sine wave output. This circuit board in the middle here, it contains the power supply for the internal circuitry to function. It has also the main processor board, which manages all of the stuff inside this UPS device, and it also sends and receives comments from this small circuit board that drives the LCD screens and the two push buttons that we have on the user interface. I forgot to mention that the toroidal transformer is connected at its input to a coil, and this coil, after a little bit of investigation, I figured out that this coil is used as a boost converter in the mains mode. When the UPS is connected to the main supply, this transformer will step down the power, to step down the voltage to a level of 24 volts, and the H bridge at this state will act as a chopper and will work with this inductor in the boost modes, and will step up the voltage a little bit higher to charge the batteries to its floating point. And that's all. This is the only functionality of this coil. In the inverter mode, it has no functionality whatsoever. From my judgment, I could be wrong, of course, but this is what I came to as a conclusion after monitoring this device in operation for hours. So let's test it. I will switch on the device and I will test a few of these circuit boards on this oscilloscope. So let's do it now. We'll turn on the device. I have the oscilloscope trough here. We'll connect it to one of the H bridges branches. We're gonna get the ground terminal first. Forgive me for being a little bit sloppy because I'm only one-handed man. I'm using the other hand to hold the camera. So here we get the signal of the H bridge, the sinusoidal PWM signal. You see it on the oscilloscope. You see a varying width signal, and at each instance, this signal has a certain width. That tells you that this signal its width is modified according to a sinusoidal pattern. So at the output, the signal you will see it amplified, and then it will get filtered to form a purely sinusoidal after signal. You will see the signal at the output here. Okay, wait a minute. Here is the sinusoidal output signal. We have to adjust the timing for a bit.
Here we are. We have a pure sinusoidal output signal. So let's test
Now the charging mode. I will hook the supply to the I will hook the cord of the UPS to the main supply. I gotta tell you, you gotta be careful doing these things. If you are not an expert, if you don't know what you are doing, don't try these things by yourself at home. It could be dangerous. It contains a lot of dangerous levels of voltages.
So you gotta know what you're doing.
Now, I have to test the, no, it is not connected yet. Yes, it is now. So we will test now the boost operation of this coil we talked about earlier. We have to change the timing for a little bit too. You see this signal? This is the boost signal that changes the battery's voltage level to charge up the batteries. I will try to draw an illustrative schematic for the circuit board. This is not the exact schematic of the device, but will show us the general operation of the circuit. So this is the last segment of the video. Stay tuned to get it.
So this is basically an illustrative schematic. It is not the exact schematic of the UPS device that we have been investigating lately. At the input, there is the P1, the battery bank that you have, and here is an H-bridge MOSFET transistors. And at the output of this bridge, it is connected to a filter, the chopper coil or the boost coil that we talked about earlier. And we have the toroidal transformer T1. This transformer will step up the sinusoidally modified pulse width modulated signal, and then it will be filtered out on this inductor capacitor filter to form an output sinusoidal waveform. What happens when you connect the input of this transformer to the main sinusoidal waveforms? Then the transformer will work on the reverse direction, and it will step down uh, the input sinusoidal waveform from 220 volts RMS to 48 volts, and then it will get rectified on this H bridge using the body diodes implemented inside each transistor. It will charge up the capacitor banks that we have on the circuit board, and then the capacitor banks is supposed to charge up the batteries. But the transformer can only produce 24 volts DC or less. So in this case, we will operate on the lower sides of the H bridge to make it connect and disconnect at each uh, sinusoidal wave cycle, and that will basically form a boost converter. We'll draw at the bottom here what is actually happening. We have uh, the input sinusoidal, let's say the positive portion of the input sinusoidal waveform here, and this sinusoidal signal is applied to an inductor, the inductor L1 we've been talking about, and then this inductor is connected to a transistor. Here we have, let's just depict it as a simple switch, and the switch is connected to the ground on the other side, and we have at the other side we have a diode here, a counter diode on the switch, and we have the other body diode of the other high side transistor connected to an output capacitor to the ground. And what is basically happening here when you switch on this switch, let's say Q2, this is the same depiction of the transistor Q2. When you turn it on, you will make the current flow in this inductor, this input inductor L1, and then the inductor will store energy during this cycle, and then once you release the switch, when you open it, the inductor uh, have to generate the internal energy into the load. So it will generate the energy through this body diode here, and then it will charge the capacitor to the battery bank that you have. And this is the configuration of this UPS and how it charge up the battery bank. But in our configuration, we are using a separate battery charger. We don't use the main transformer because we are using a normal switch mode transformer in our case. But in this case, he's utilizing the toroidal transformer that he had. He's using it to charge up the batteries and also to generate the pure sinusoidal output. It is really a smart move, but we are not going to use it anyway. Thank you for watching this video and see you in the next video, and hopefully it will be the testing of our design, the UPS unit that we have created, and probably I hope it should work. So until we get to that point, as usual, don't forget to like our Facebook page, My Green Egypt, and don't you forget to subscribe to our YouTube channel. See you in the next video, and goodbye.